Hello everyone and welcome back. Today we're going to continue with primary trigonometric ratios, but we're going to advance a little bit further. We are going to solve word problems using primary trigonometric ratios. Again, please remember at the end of the video, after you have completed your notes and reviewed the video or the PowerPoint, come back and check the I can statements. In addition to what we talked about in the last lesson, you need to be able to draw your own triangles based on the given word problems, as we're going to illustrate on the examples today, and understand what is an angle of elevation and angle of depression, and how to use this solving word problems. Let's start with this first example. Jamie's kite string is 35 meters long. It makes an angle of 50 degrees with the ground. Determine the height of the kite. Okay, so we can draw this triangle, the string. We know that it's 35 meters long, and we know that the string creates an angle of 50 degrees with the ground. And we're asked to determine the height of the kite. The height of the kite. Okay, so from the point where the kite is, we're going to take a vertical point to the ground. And as we did the other day, the very first thing that we're going to do is label this triangle as opposite, hypotenuse, and adjacent. Okay, we do not have any, this is what we're looking for the opposite. We have the hypotenuse, and we're looking for the height of the kite. So what kind of information do we have here? Hypotenuse and opposite. Therefore, the ratio that we're going to choose is sine of angle B equals opposite over hypotenuse. Let's plot the information. We have sine, the angle B is 50 degrees. Sine of 50 equals x over 35. Multiply by 35 both sides. Sine of 50 multiplying 35 equals x, that is the height of the kite above the ground. Okay, so very similar to what we've seen so far. The only difference is that we have to label the triangle. Most of the times the triangle will not be given to us, and we have to draw the triangle based on the given information. Another thing that we are going to look at today is the angle of elevation and the angle of depression. Let's look at this picture here. We have a dog looking at the bird up on the tree. The angle of the elevation is the angle created by the line that connects the view from the dog to the bird with the horizontal line from the eyes of the dog. Okay, from the eyes, not from the ground. So the angle created by the line that connects the 2 points that we're connecting, the eyes of the dog with the bird, with the horizontal line from the point view. The same thing here, the angle of depression. If the bird was looking down at the dog, that's what the angle of depression is when you look down, is the angle created by the same line, and then again by the horizontal line of the eye level, or the point of view of the observer. Okay, so just notice here that these two angles are equal to each other. The eye level, horizontal line, they're parallel, and this is the line that intersects with both these parallel lines. Therefore, the angle of depression equals the angle of elevation. However, you have to be able to identify where the angle of elevation will be and where the angle of depression. Angle of elevation when you look down, up, and angle of depression when you look from up, down. Okay, and it's always the angle created with the horizontal line from the point of view. Okay, hope you understand that. If not, please let me know. I can explain to you in a different way. Let's look at the example 2 here. Okay, a tunnel is to be made through a hill from A to C as shown here, from A to C. the angle of elevation to the top of the hill from points on opposite side of the hill, but on the same level, so A and C are on the same level, are 29 and 44. So from point A, the angle of elevation, we're looking up to the top of the hill, is 29 degrees, and from point C, the angle of elevation is 44 degrees. Again, is this angle here because we're looking from the bottom to the top of the hill. The top of the hill is 500 meters above the tunnel. So this is the top of the hill. We're taking a vertical line every time we talk about height. Okay. Find the length of the tunnel joining points A and C to the nearest meter. All right. To find point AC from the given information here, we have to divide this into two different triangles. Triangle, let's label this D here. Let's have this point D. Okay, so triangle ABD and triangle BCD. Let's look first at the triangle ABD. Okay, let's change this into red. The given angle is angle A here. This is the hypotenuse. Opposite angle A, we have this here, and then we have the adjacent. Okay, we'll label the adjacent as X. Adjacent equal X. Okay, now on that triangle, what do we need here? We need the adjacent. We need AD. Okay, so AD is what we require. We have opposite, so we have O and A. Which trigonometric ratio we need to use? Tangent. So tangent of angle A equals opposite over adjacent. Let's plot in the information. Tangent of 29 degrees equals, opposite is 500 meters over A or X. Now we need to isolate A. Okay, so how we're going to do that? Multiply by A both sides, or if you remember the triangle, the pyramid. So we have tangent here, here is opposite, and here is adjacent. We need adjacent, so we're going to cover that. So A equals, then we have O over tangent. 500 divided by tangent of 29 degrees. Okay, from where A, putting that into your calculator, is approximately 902 meters. Okay, but we also need to find this other part on the triangle BCD. AC, let's write this down here. AC, the length of AC that we require to solve is AD plus DC. Okay, we figured out what is AD, 902 meters. Now we have to figure out what is the length of DC. Keep in mind this triangle is not to scale. On the triangle BCD now, we have angle C. Opposite angle C is again the height BD. So let's label this again. Oh, this is the hypotenuse. And the adjacent is right here. And let's label that adjacent here. Let's notate it as Y. Okay. In this triangle now, we need A and we have O. We have no information for hypotenuse, so we can cross that out. Again, O and A, we're going to use tangent. So let's start again here. Tangent of angle C in this case. Let me erase this. Okay, tangent of angle C equals opposite over adjacent. Angle C is 44 degrees, so we have tangent of 44 degrees equals opposite is 500 over y. Okay, again here we can use the same pyramid triangle here. We have O and tangent, we need A. Cover A, y in this case, y equals 500 divided by tangent of 44 degrees. Put that into your calculator. Y equals 500 17.8. Okay, that is the value of y. Now we can come back here. AD or x here is 902 plus 517.8. That will equal to 1419.8, but we're asked to the nearest meter, so that means that the height of the hill is 1,420 meters approximately. That here should be rounded to the nearest meter. Okay, so 1,420 meters. All right, so that's how we are going to approach these problems. It's very important that you fully understand the question, what is asking, and where you need to find that information. All right, let's move to the next example. Safety by laws state for a ladder to be stable, the angle the base of the ladder makes with the ground should be between 70 degrees and 80 degrees. A safety inspector at a construction site noticed a pointer on a 10-meter ladder that is leaning against the wall. The base of the ladder is 1.5 meters away from the wall. Does the inspector have a case to be concerned? Explain. Okay, so let's look what we have here. We have that the safety tells us that the angle between the ladder and the ground should be between 70 and 80 degrees. And let's say this is the wall where the ladder is leaning, and this is the ground, and the ladder is 10 meters long. Here's the ladder, 10 meters long. Okay, this is the ground here, creating a 90-degree angle with the wall. And what other information we have? We have that the base of the ladder is 1.5 meters away from the wall. Here is the base of the ladder, okay? And this is 1.5 meters away. Okay, you can make this as a building here if you want. Okay. Now let's solve this. We need to know what is the angle here. Let's label that angle theta. What is the measure of angle theta? The very first step is labeling this triangle based on the angle theta. We have opposite, hypotenuse, and adjacent. Okay, what do we have? We have no information here. We have no information for opposite, and we don't require to solve for the opposite. So let's eliminate that. We're left with hypotenuse and adjacent. So which one of the trigonometric ratio has those two? Cosine. So there we go. Cosine of angle theta equals adjacent over hypotenuse. Let's write the information. Cosine of angle theta equals adjacent is 1.5 over 10. Now we're solving for angle. To isolate theta, we need to take the inverse of cosine. Theta equals inverse of cosine of 1.5 over 10. Okay. Putting this information into your calculator. So putting that into your calculator, we will get angle theta equal approximately 81 degrees. Okay, rounded to the nearest degree is 81 degrees. Now, we got the angle that the letter creates with the ground is 81 degrees. We need to go back now to the safety rule that it says that the angle created should be between 70 and 80 degrees. That means that yes, we do have a case, we do have a concern because the angle created by the letter is not safe. Okay, so that's how we approach this problem. Let's look at another example. All right. While walking to school, you pass a barn with a silo. Looking up to the top of the silo, you estimate an angle of elevation to be about 14 degrees. You continue walking and find that you were 40 meters from the silo. Using this information and your knowledge of trigonometric ratios, calculate the height of the silo. So as you are standing at this point here, you notice that from your point of view to the top of the silo, the angle of elevation is 14 degrees. And then you figured out that the distance where you measure that angle from the silo is 40 meters. Okay, so once you properly created the triangle, most of the times the triangle will not be given to us, so we have to use the information from the word problem step by step to draw the triangle. Okay, so you start by drawing the silo. You were here, the angle of elevation was 14 degrees, and then you know that the distance from you and the silo is 40 meters. And we're asked to solve for the height of the silo to figure out how tall is the silo. The very first thing is labeling the triangle as opposite, adjacent, and hypotenuse. Angle 14, silo is the opposite. This is A, and hypotenuse is here. We have no information for the hypotenuse, so we can fully ignore it. Which trigonometric ratio has both opposite and adjacent? Tangent. So we write tangent of angle theta equals opposite over adjacent. Plot the given information. We are missing O using the pyramid. You multiply tangent of angle 14 degrees with side A. Then you get that the silo is 9.97 meters. Okay. The next example. A wheelchair ramp is needed at the entrance of a restaurant. The ramp is to be 6.10 meters long. So understand here what is the given information. Okay. So the ramp is, so there is one information. The ramp is 6.10 meters long and have a rise of 6.45 meters. Calculate the angle of inclination or the angle of elevation, that's what it stands for, of the ramp. So which one of these angles are we talking about? The angle of elevation from top to bottom, we said when we look from down up. So this is the angle of elevation. This is the angle that is required to solve. Okay, so let's label that angle theta. Okay, let's label the triangle from angle theta. Opposite, hypotenuse, adjacent. Now we have information for hypotenuse and opposite, but nothing for adjacent, so we totally ignore that. Which one of the trigonometric ratios has opposite and hypotenuse? Sine. So we write sine of theta equals opposite over adjacent. Sine of theta, plot the information that we have. Now we're solving for angle here. Okay, so we're going to take the inverse of the given ratio. Inverse of sine equals 0.45, theta equals inverse of sine of 0.45 divided by 6.10. Carefully plot that into your calculator, and the angle of inclination is 4.2 degrees. Okay, pretty straightforward. Again, be careful, pay attention to how the triangle is designed and where do we put the information that is given from the word problems. So in case you don't have this triangle, the triangle is not given to you, you will be able to draw the triangle and put the information in the proper places. The last example that we're going to view. A helicopter sights a campfire at the angle of 40 degrees from the horizontal. The helicopter is hovering 400 meters above the ground. What is the horizontal distance between the helicopter and the campfire? Okay, so let's see now what kind of information do we have. We have the angle of 40 degrees from the helicopter to the campfire. That means that this is the angle of depression. So this is the angle of depression here, 40 degrees. What else do we have? We have the height of the helicopter from the ground, 400 meters. And we are asked to find the horizontal distance between the helicopter and the campfire. So we're asked, this is the horizontal distance that we're asked to figure out. All right, now first let's make the connection here. The angle of depression is outside the triangle that we can create here. But as we mentioned earlier, this angle is equal to the angle here. Okay, these two angles are parallel. These two lines are parallel. Therefore, these two angles are equal. So 40 degrees. And now in this triangle, we have the angle and we have the length of the opposite side, and we're required to find the adjacent. We have no information for the hypotenuse, therefore we can fully ignore it. Which one of trigonometric ratios has both opposite and adjacent sides? Tangent. So we write the tangent ratio and we plot in the given information. Tangent of 40 degrees equals 400 over side A. Using the pyramid here, side A, so cover that, and you have opposite over tangent, 400 over tangent of 40 degrees. Putting that into your calculator, the horizontal distance is 476.7 meters. Okay, so the only challenge in word problems is to properly draw the diagram and input the information where it should be. The rest is you're going to end up solving a right angle triangles. You're going to, after you're reviewing this PowerPoint again, I would like you to complete the mindful notes using these notes here and solve the 3 questions that you're going to find on that handout. Okay, again, if you have any questions, don't hesitate to reach out. Talk to you later.